Hey everybody, this is Mark Smith, host of Digital Roughnecks, and I'm here with Paul Gibbs, the founder of Xtreme Tank Technologies. Hey Paul, thanks for being here.
Hey, thank you, Mark, for having me.
Paul and I met at a Fuse conference in Houston, and you actually solve a problem that we see, all the time. And so anyway, tell me about your background and kind of how you came across this problem, decided to jump in.
My name is Paul Gibbs. I am the founder of Xtreme Tank Technologies. My original patent on this tool was 1990. What we talk about today is new to people, but it's not new to me. I've been doing this for 32 years. A few years ago, I decided to leave the work world. I get kind of tickled when I hear the politicians say that, technology will come around to reduce methane emissions. Well, I've been doing it for 32 years now, and I've been waiting on the laws and rules to show up for me. We do need to clean up our act. I spent the last 25 years in a refinery. I ran atmospheric distillation and vacuum distillation and propane de-asphalt, reformation, naphtha hydrotreating. So I took crude oil and heated it up to 685 degrees. I took naphtha, took it to 945 degrees. I know what it's like to take a liquid and make it into a vapor. And that's what happens inside of a tank is we have vapors that form and come out of the tank. I know what's happening inside that tank. And it's been around since 1948 of vapor recovery off of tanks. And we really never changed that. Before 25 years at the refinery, I spent 10 years with a company called Mobil Oil Company, back before it was ExxonMobil.
Well, let me set this up for you, and then I'll tell you why I really wanted to bring you on here. But CleanConnect, we get into this whole VOC gas leak detection and quantification, right? Our ideal is to see how can we automate for companies that want to do autonomous LDAR, right? This is the most common way, a guy with a FLIR camera going around a site. And with the new Quad O, B, and C, that's going to minimally grow to double the frequency and for some Quad O, C may grow for some companies, 7 times more than what they do today. So what we do is we put an OGI camera up there 24/7. You can see here on the site, one OGI camera covers like every upstream site we've ever done. And you can see what it looks like up here on the left picture there. We'll have an OGI camera. We'll also put up optical cameras and other things that we do. And what we do there is we allow someone to do a tour stop, right? So each one of these stops, we can zoom in on a particular piece of equipment or equipment group. We can do inclusion and exclusion zones. And and you can see here's cold venting, right? Raw footage of cold venting, and then we're allowed to quantify it, measure it, and alert on it. You can see some more venting here. And then another very common thing is when tanks over pressure, right? And so you have gases leaking out of that kind of stuff, and pressure relief valve opens. And here's another thing that we see, load out observations, where pump truck shows up, may not connect correctly, causes an emission event. And, of course, we can see all that kind of stuff. And so I put this pie chart together, and I was asking my guys who've been running this for a couple of years, what categorize these into broad categories? Okay, well, 60% of what we see is cold venting, 30% tanks overpressuring, 7% load out, and then there's other, right? So when you tend to think of leak detection, you're thinking, oh, some random part that needs to be tightened down. But really, cold venting is, a category of a combustor not combusting because a pile light might have gone out or something. Tanks overpressuring, what we see, because we also do tank level monitoring using our camera, what we're seeing is, if liquid goes up and down really evenly, everything seems to be cool. But if there's a slight surge going one way or the other, some of the pressure relief valve can open and whatnot. With CleanConnect, we like to not only, help people find a leak, fix a leak, but also fix the problem so that it doesn't recur. And it's something that really needs to be done now, because these new Quad O, B, and C, they came out with a new regulation called the super-emitter event. What happens is they're going to be flying satellites over every day. Okay, and if they find an emission of 100 kilogram per hour, they give you a notice. Sort of like you driving on the freeway, and boom, a few days later, you get a notice in the mail with your picture and your car, and it's saying you owe me money, right? This will be the same thing. Hey, here's a picture, and with your site underneath it going, hey, there was a super emitter event, you owe me money. And you have 5 days to go find out what it was. And, you know, they even list the most likely cause of the problem: cold venting, tanks, overpressuring, thief apcho. So the EPA sort of knows this is a common occurrence, right? And then by day 15, if you can't prove that it wasn't you, you're guilty. And you'll have that super emitter event will be posted on a public super emitter EPA website saying, hey, you did this. And after 3 of those violations, they don't really say what exactly would happen, but they are sort of hinting that you may get a consent decree, which was a nasty gram, right? So, you know, for us, you know, we like to say, hey, if we can not only fix the problem, but even make it so that some guy doesn't have to drive out to his site. Like in Colorado alone, if we could eliminate 80% of the call outs, that's 545,600 call outs, and eliminate the number one hazard, which is, you know, guys getting in accidents on the road, right? And you could eliminate a lot of that stuff. This came from my EPA cheat sheet on the new regulations, which you can get here at www.epacheatsheet.com. But with that in mind, now I've kind of set you up, right? And I've told you that 30% of the problems we're seeing are tanks emitting. So why don't you share your screen there, Paul, and show us what your product does in terms of eliminating that problem from ever happening.
Let's talk about what we do today. Traditional vapor recovery on a fixed reef tank for the exploration world, and also the refining industry and some of the midstream people. They'll have a fixed reef tank. We capture the gases off the roof and we come down to a compressor and we pump them off. And the way we do that is we have a pressure transmitter on this tank. Let's say at 4 ounces, that it tells the compressor to come off, and at 1 ounce, it tells the compressor to shut down. That's what we've been doing since vapor recovery was invented. We haven't changed it now. We have an Nardo valve that's our pressure relief valve that leaks the pressure off if this compressor can't handle it, or if the compressor goes down. Our thief hatches are also designed as pressure reliefs. So this is what we've been doing for years. And I hear you talk about intermittent tank leaking. 30% is what you are saying. That's good numbers. And I would imagine the majority of what you have a camera on has got vapor recovery. So why are they leaking? The reason the majority of tanks leak, even when you have vapor recovery, is today vapor recovery is people are removing what works its way out of the tank, the vapors. The vapors flash out of this oil and they have to travel up. The heavy molecules condense back. They don't make it out of there. They hit the wall of the tank. They hit the roof of the tank. They form a droplet. They fall back down as a liquid. It's not crude oil. It's a volatile gas. It's going to reflash. So you have this never-ending cycle of flashing and reflashing and reflashing, and it can't get out of the tank. You have more oil that shows up, more heavy molecules are flashing that can't reach the roof of the tank. And today, the oil producers are buying taller tanks. I mean, back in the 80s, every tank out there was 15 and a half, 16 foot tall. Nowadays, they're 30 foot tall. That's just more travel that gas molecule has to do to get out of that tank, which leaves more heavy molecules that didn't get out of that tank. What happens is you go to 4 ounces, your compressor comes on, and then these heavy molecules will flash, and you go to 13 ounces, and you leak for 30 seconds, 90 seconds, 120 seconds, whatever it is, the time frame might be, until it releases itself back off. Your compressor's out here running, you've been perfectly fine, and all of a sudden you think, man, did I get a surge, the temperature change? Well, you have two-phase vessels in front of you. You have three-phase free water knockouts. You have three-phase heater treaters. You have all these surge protectors in front of you. So what changed? Nothing really changed. Our problem is we're not stabilizing. We're not removing what flashes. You're only removing what works its way out of the tank. In Xtreme Tank Technology, we work internally inside the tank on the liquids level. Oil has not seen atmospheric pressure before. It's flashing vapors out like crazy. This is considered the flash zone in the world of distillation. The most volatile active area you have in a tank is right above the tank's liquids, where all the gases are being released out. That's where we're working. That's where we're taking suction. There is no heavy gas molecule that can't make it to the suction. We're 5 or 6 inches above the oil. As soon as it flashes, we remove it. We stabilize the liquid. Apples to apples, if you're doing vapor recovery off your roof and we add our tool, you will see an increase in BTUs. Why? You're not grabbing the heavy molecules that we will. We will actually pump off more gas. Why? We're grabbing the heavy molecules that you are not grabbing. We stabilize as liquid. I tell people, you remove what makes it, what works its way out of the tank. I remove what flashes in the tank. It's total carbon capture. We're in the area where the gas molecule is being released. We're not 8, 10, 12 foot away, 15 foot away, and a roof in the way. And you know, in the gas business, when that gas molecule hits that roof, we call that a demister pad. That's an obstruction of that gas molecule to dry it out, to knock the moisture out. When you open your thief hatch on a tank, you'll hear it raining inside the tank. For years, I thought that was oil that had just been splashing around in there. That's gas molecules that are condensed, that are dropping back down into the liquid. They're going to reflash again. They're a gas molecule. And that's where we change things, is we go in there and we address the most active area that there is. And this same compressor that you have today, we're changing the process. And the process is we work in the most active area that there is. And this tool is multifunctional. We do a dozen tasks: stabilizing your tanks, stopping intermediate tank leaking, stopping. Mark's camera will be bored now. There'll be no more gases coming out of the tank's roof, out of the Nardo valves or out of the thief hatches, because now we're capturing them all. And another thing Mark's camera does is it has heat and fire detection on it. Well, guess what this tool is? This tool is also a type 1 tank fire tool. If your tank catches on fire, the number one cause of a tank fire is a leaking thief hatch, by the way. That's from the insurance board. I stop that from happening. So risk reduction. All right, now then, your tank is on fire. I can have stored fire foam sitting outside that will be with Mark's camera. We'll put the fire foam, it'll say fire. I'll have 350, 400 PSI of nitrogen push on this fire foam. The foam will enter the tank and put out a tank fire, unmanned, automatically. And your cold temperature states, Colorado, and North Dakota, and Utah, and Pennsylvania, and Alaska, and you know, they might plow the roads to get you to work, but your lease roads are generally not plowed. Fire trucks can't get to tank batteries several months out of the year. I can literally put out a tank fire faster than you can dial 911 and turn it in. And the reason we work so well, the fire foam never travels through flame. Fire foam is water and foam mixed. If I go through a flame of 2,000 degrees, it's turning to steam. It does not splash. I don't splash oil up and out of the tank. If the roof got blown off, you don't want oil coming out of your tank. If this was the real thing, Mark's camera right now would say fire, and my valve would open, and I'd be putting that fire out. You'll see a red hose at the bottom of this tank. It's just a 1-inch radiator hose. I'm gonna put this tank fire out with a 1-inch hose. This is my tool that's in the tank. It's taking the vapor out 24/7, 365, keeping you compliant in any state, no matter who's in Washington, D.C. We let this tank get fully engulfed before we do anything with it. You'll see some words pop up here in red ink. That's the marking the time that we open up the 1-inch valve. So we're on fire. The camera says, hey, there's a fire. The valve just opened, and with a 1-inch flow, if your roof is still remaining on your tank, your fire department can't do anything. They can tie onto a line on the outside of the tank that's a safe distance away, a football field away. You put out tank fires just like this, and you do it in a matter of seconds. That's a 60 gallon a minute flow. I can put 2,000 gallons a minute through it. So that's some of the things we do Xtreme. We take your tanks, we put them environmentally safe. We stop them from intermittently leaking. And this is the icing on the cake. It's the same tool. It doesn't cost any more. It's in your tank. You can set your tanks up with an automatic system. Outside the tank, you can run an 1.5-inch pipe, like I said, a football field away. A fire truck can show up a football field away. You can have a fire department extinguish it. They all go home successfully and safe. That's the last thing we want is people hurt or killed on our sites.
So once that device goes in there, like how long will it last? Does it need to have maintenance or?
Right. There is no maintenance. There's no rotating parts to this tool. There's some internals to that tool that is designed to rifle the gas, to keep it suspended, to get it out of the tank. It's also designed to expand the fire foam. There is no rotating equipment. I have had it inside some of the nastiest water flood, saltwater, secondary injection sites, water flood stations, tanks for 21 years. And that was some of the highest chlorides you can imagine. That water weighed, 11.5 pounds. I don't know. It recycles over and over and over again. H2S was, way, way high. So in 1990, we installed it. In 2011, the company tore down the facility and rebuilt it. And that's the reason they pulled the tool out, because the tank was going away. Now, it looked like it'd been through a war, but it still worked. And it's been in that tank for 21 years. So that gives you an idea of this tool is from one end to the other, 316 stainless. We do that for two reasons: the protection of the metal, and if there's a fire. The melting point of stainless is way much higher than the carbon steel of the tank. So it will still be putting out fire foam when your tank is a puddle of metal, so to speak. So on the carbon credit thing, if you sell your gas, they don't give you a carbon credit. If you take the gas and do other things like power generation, you can get carbon credits. So that's their rules as of right now, as far as I'm understanding. But yeah, we work with we make power from that. You can do numerous things. Bitcoin miners can show up. There's a company I'm working with. They have a really cool new technology. It's zero carbon footprint, by the way. It's all about plasma. So, to me, I think of like I'm a microwave. I can heat something up and not be using anything that's going to emit. I'm just using electricity. Well, the electricity I make with this technology, that it makes two things. It makes graphene and it makes hydrogen. I can take the hydrogen and you can run a hydrogen genset, zero emissions. And then you have graphene that you sell. And it's some new technology that comes out of Cambridge University, and they're scaling up to 5th oil field. They've been doing it for a while, but they've been doing like landfills and things like that. They are being successful. They're scaling it up to where we can go to a tank battery that's got 6,000 barrels a day coming into it. And they can handle all that volumes of gas. So that's their, and I hope to be there in the next 12 months for that scope of size. But I'll tell you this, we're selling so fast, you better get on the list if you want to get on the list for them. But yes, at Xtreme, we do many tasks. I'll tell you one that I'll tell you. It's also about the emissions. It's in the water business, saltwater disposal side. I remove the oil off your water tanks. Oil is emitting. If it's gone, it's no longer emitting. And I do that. I skim the oil no matter where, because I'm floating on top of your top liquid level. I remove your oil off your water, no matter if you're at 6 foot or 32 foot in your tank. I know every tank out there has got a skimmer on it, and all it is a pipe on the side of the tank. And you have to get your level to that certain point. That's a lost art, and no one has time for that. You have to ease it up every 30 minutes. You don't have time to let that tank sit idle while you skim oil off of it. With my tool, we generally have a pin timer that comes on for 15 minutes every hour, every 2 hours, every 4 hours, depending on how much oil you have building up or you're carrying over. You never have oil on your tank. And instead of removing any gases in the saltwater disposal business, we will put gas in. We'll take gas from the tank battery. We will release it with my tool at the surface of the level, and we will remove it off the roof through the traditional way. But by doing that, we're sweeping the tank, making sure there's no oxygen in there. The difference between a tank fire and a tank explosion is oxygen. Another risk management. In North Dakota, tanks were blowing up and becoming Apollo 13s. You know, they were going 200-300 foot in the air. That even the state got involved with that, and the state legislation and North Dakota State. And I even worked a little bit with them on that. And it's all boils down to sweep your tanks, get rid of the oxygen. Another risk reduction. You're not using the gas, you're just borrowing it, sweeping through the tanks and going right back to your sales line. It's something that is helping that industry big because they do have problems there with oxygen in their tanks. They do explode, and no one wants to be around that. But yeah, our tanks, we take down, we capture in the correct area, and we're capturing every gas molecule that flashes from your heaviest to your lightest. I even have people who ask me this question, and it's been coming up a lot lately: H2S. If you're dealing with sour fields, let's say your field is, they're testing it, say it's 50,000 parts per million. Your tanks might be 100 parts or 150,000 parts per million, because H2S is a heavy gas, and the heaviest of the heaviest will stay in your tank, which is a higher H2S number and a higher acidic number, which eats your tank up, metal of your tank up more, causes more problems. That's why so many people die around tanks. It's because it's the highest number that there is. I don't allow that to happen. I don't allow that number to build. I don't allow anything to sit at the bottom. I remove what flashes. I don't do away with H2S, but I don't allow that number to build. And so it does help on the safety aspect. It does help on the corrosion aspect of it. And of course, it also helps by stopping tanks from intermittent leaking. I've even had cases here in West Texas where sweet crude oil was shutting them down at the gas sales meter. They have a GC analysis computer that runs everyone out here, and it will break it down and tell them how much of it: pentane, propane, methane. It breaks CO2, oxygen, H2S, and it was shutting them off from H2S. They had a trace of H2S. Everyone does. It wasn't enough they had to worry about H2S. But the problem was H2S was the heaviest gas, and it was staying in the tank. It was not leaving, it was building, and it would build and build and build, and it would burp out when it got full enough. And it only lasted for 2 minutes coming across that flow meter, but it only took 10 seconds or 15 seconds, and it shut them down. Put my tool in, the problem went away, because we don't allow anything to build up like that. It's never shut them down again since. That was a couple of years ago.
Paul, I want to thank you for being, giving us a solution to a pretty common problem out there in the oil and gas space. So thanks again for being on Digital Roughnecks.
Hey, thank you.